So this question is question 2B from the homework, which is the end of chapter 5 questions, and involves an astronaut placed at point B, rotating on a beam clockwise around a pivotal point at A. So we've got circular motion questions coming in here, tied into simple harmonic motion questions. Okay, so the astronaut's going around in a circle and will be accelerating centripetally towards the centre of the circle. So don't forget, we've got A is v squared divided by the radius. Okay, and we're also going to look at simple harmonic motion here from the previous part of the question. So if you look at that sketch of that graph there, which is showing you displacement on the x-axis against acceleration on the y-axis. So when you have a displacement of 50 millimetres, your acceleration is 50 metres per second squared. And this relates to the mass on a spring system, which is sketched below. So you've got this oscillating mass between two springs, and you're showing what the acceleration is at various displacements. Okay, so that mass on the spring system is actually your accelerometer. Okay, and it's talking about what is the acceleration when the deflection, which is also the displacement, is at 50 millimetres. Okay, so from that sketch graph we can see that at 50 millimetres the acceleration is 50 metres per second, and that's important in a moment. So if we think back to the motion of the astronaut going round in a circle, okay, it's got a constant speed because the rotation is constant. Okay, so the velocity is changing because it's changing direction, but the speed is constant, and so therefore the central petal acceleration towards the centre will be constant. Okay, so now we're coming on to the very final part of the question, which is asking you what is the speed, what is the velocity of the astronaut, okay, given that there's a deflection of 50 millimetres on the accelerometer. Okay, so we're now looking at centripetal motion acceleration equation, which is A acceleration is v squared divided by r. Okay, and don't forget the radius of the beam is 10 metres. So simple rearrangement of A is v squared over r gives v squared is AR, so v is square root of AR. So we found out from our accelerometer the acceleration is 50 metres per second squared, and the radius of the beam is 10 metres. So substituting in those numbers, v is square root of 10 times 50, which is the square root of 500, which comes out to be 22.4 metres per second, that should be. So that's how fast the astronaut is going on the beam. That's the velocity of the astronaut. Okay, which concludes question 2, which people did find quite challenging.